Okay, so good afternoon, everyone. So today we'll be discussing the assignments related to week 3 content of the course. So let us start. Before I start, once again I say that this session will be recorded and it will be shared on YouTube. And you can also go through that YouTube channel and watch this assignment discussion. And you can post some questions if you have at any time, and you can post that question in the YouTube channel, and I will try to respond it back to that question. So with that, let us start today's session. So, so today we'll be discussing about this week 3 content, which is basically more about this forward and inverse kinematics and some of the continuous from the DH parameters. So the first question for today is that in in these, which configuration will give a cylindrical shape workspace? So here the cylindrical shape works by cylindrical shape workspace means that the end effector of the robot which we are talking about or which we are desire should cover a cylindrical workspace. For example, if you can see here in the right side, so this is this is a cylindrical workspace or cylindrical work envelope of a robot. So this is the robot. So as you can see here, so what you can see here is this one rotation here, and then you can see there is one translation, and then again there is another translation in other direction or perpendicular to the direction which we have this translation earlier. So this is clearly so if you look to here, this is clearly a rotation followed by a translation followed by a translation, or this translation is generally called represented by P. So this is what, so there are two P and one R. So, but how is that like related? So we have one R, two P here, one, and then for this only one. So, and but there is parallel and perpendicular, right? So that you also have to look whether this is correct or not. So the thing is that here, as you can see, this rotation, if you do the rotation, what will have, you'll have a coverage like this, right? So this whole thing will be moving in a circular fashion, but that doesn't mean that it will have a cylindrical. So cylindrical, what will have, these circles should be traced back and forth, right? So there should be a translation or a P. So this translation, as we know that we give Z here for this translation motion and our prismatic motion, and the same Z we are moving along the same like the rotation is also having a rotation is also there along the same Z, or rather the two frames which you consider for DH parameter, the Z0, suppose if you write Z1 or Z2, this Z1 and Z2 will be parallel. That means that the rotation frame and this translation frame are parallel. So you can say this R is parallel to P. Now the third one, this one, as you can see, this is perpendicular to both R and P, right? The earlier R and this P. So you can say this as perpendicular to P, and this is also a prismatic joint, right? So uh, what will happen? This will the first art will trace the circular path, and this will track back and forth the height of the cylinder, and then the length will be varied by the last P translation. So in this case, what will you get? We'll finally get a cylindrical type of workspace, right? So this is how we'll get a cylindrical type of workspace, and the required configuration which we want is of RPP. That means R parallel to P, and whole thing is perpendicular to the last P. So this is the correct answer for this question. Understood. So let us move to the next question. So here we have like this is what, for a special serial manipulator, the forward kinematic relations are given as follows. So we have X equation, Y equation, and Z equation. So let us try to solve this. So what we have, this X equals to cos theta Right. So here we have x equals to cos theta 1 a2 cos theta 2 plus a3 cos theta 2 theta 3 and sin theta 1 a2 cos theta 2 a3 cos theta 2 theta 3, right? And z equals to d1 plus a2 cos theta 2 plus a3 cos theta 2 plus theta 3 or theta 3, right? So so the question here is how will you like if it the theta 1 equals to 0 is given, what will be the value of theta 3? So we have to like do what? Inverse kinematics. We want to find out the theta values given the, or theta means that joint parameter given the actual positions x, y, z and orientation. So how will you do that? So we'll try to use this trigonometry and we'll try to find it out. So let us put the theta 1 equals to 0 and or theta 1 equals to 0 and see how it goes. So if you put theta 1 equals to 0, what we'll have is x equals to a2 cos theta 2 plus a3 cos theta 2 theta 3, and y will be equals to 0 and z will be equals to d1 plus a2 cos theta 2 plus a3 cos theta 2 minus theta 3, right? So this is one. Now we can see that this is same as this thing. So we can write z equals to d1 plus x. That means x equals to z minus d1. So uh, so we have x equals to z minus d1. Now if we take x square, what we'll get? We'll get a2 square cos theta 2 plus a3 cos square theta 2 cos theta cos square theta 3, right? So basically so if you plus we'll get a2 a3 cos square theta um, cos theta 3. So if we solve, what we'll get if you take cos square theta 2 a2 square plus a3 square plus uh, sorry a3 square cos square theta 3 and plus a2 a3 cos square theta cos theta 3, that is cos square theta 2 to a2 square plus a3 square plus a2 a3 cos theta 3. So this is what we will get as x square. Similarly, so well, there is no space here, so let me erase that this part. So similarly, if you play, you will get some y equation similar to this, right? So we'll get that equation, and if you put that into, so we don't have a space here, so So I will give this as a segment or a practice, because the more practice you'll do, you'll have this better understanding of this. So if you put this into the equation and try into this equation and use this value of y, what we'll get is we'll get as x square plus z minus t1 square minus a2 square minus a3 square by 2a2 a3. So this is when we have y equals to 0. Thing is, we'll get it as x square plus y square plus z minus t1 square minus a2 square minus a3 square by 2a2 a3. So here the as theta 1 equals to 0, so y2 will be equals to 0. So because if theta 1 is 0 here, we will get as 0. So the the final expression which you'll get is this one. So the correct answer is x square plus z minus d1 square minus a2 square minus a3 square by 2a2 a3. So this is what you get. So what you have to do, so again I will tell. So you just have to once use this theta equals to 0 value and try to find out the relation between x, y, z, and then eliminate theta 2. And after eliminating, you will get one equation with theta 3 and other knowns, and then you try to find theta 3. That is what we already did, right? The same question we have here as well, question number 3. So the same question, the same equations are there. It is saying this find theta 3 without theta 1. So there, whatever expressions we got, it was like this one, z minus d1 square minus a2 square minus a3 square by 2a2 a3. So there y was equals to 0, but here it will not be a 0 because there's no condition on theta 1. So in general, the equation will be this. So simply, as we have solved the earlier question, the correct answer will be this for this question. So this is just a repetitive of that question. So I suggest that you do this again by yourself so that it will be clear. If you not get it, I will try to explain it in further details in the next discussion. So the next question is question number 4. So this is also similar to what we have discussed in the earlier question. So this is pretty easier than the earlier. So here we have the forward converters is given by x equals to d cos theta and y equals to d sine theta. So this is simply what we have to find is that d and theta. So there are two equations and two unknowns, d and theta. So what we can do, as you can see from here, we can simply square both equations. We'll get d square cos square theta, y square d square sine square theta. Right. So if you do this, what we'll get? Try to do. So these are the two equations. So if you add equation 1 and 2, what we'll get? X square plus y square equals to d square sine square theta plus cos square theta. Now this is what? This is equals to 1. So we have x square plus y square equals to d square. Now, so we wanted to find out d. So d will be x square plus y square. So under root of x square plus y square. Right. So this will be the required d. Now we have d and we have this equation. So we can put d here, and or rather we have x equals to d cos theta and y equals to d sine theta. So if you divide 2 with 1, what we'll get? We'll get y by x equals to uh, tan theta, right? So if we take theta, then we can write it as tan inverse of y by x. Also, the other way which we can do is that we can, whatever d we have got, we can put here like x equals to d cos theta. So you can put root x square plus y square into cos theta. So we can, from here also you can write that theta equals to nothing but cos inverse of x by under root x square plus y square. Or similarly, using this equation, you can write theta equals to sine inverse of x by under root x square plus y square. Now the here the options which are available here is in terms of tan inverse. So we have to choose this one, right? So this and this is the correct. So d root x square plus y square and tan inverse y by x. So this is the uh, uh, sorry, not this one. This is the correct answer for this question, question number 4. So fully, so you can see here, these are the correct answer. So these are the questions which are like there to find out how we can find the how we can solve the inverse kinetic equations to find out the joint parameters once the end effector positions are given. Now let us move to the finding the DH parameters. So here we want to find the DH parameters of second joint. So by second joint means here is what we are trying to find out the DH parameters of this joint. So let us find out the DH parameters of all the joints. So for DH parameters, what all things we have. So first, let us make the table. So one is alpha I minus 1 and a I minus 1, then theta I and di, right? Or di or theta I, whatever can order you can take. Now we know that these two are measured with respect to what? Xi minus 1, and these two are measured with respect to Zi, right? Now let us write these parameters for all, and then we'll simply check for the options which are available for second joint, what we have done. So for one joint means for Z1, so this is what, this is just a serial number. So for one, so see this first joint. So what we have, we need to find alpha I minus 1. So alpha I minus 1 is what? The angle between Z0 and Z1. Sorry, the angle between, what do you mean by this alpha I1? The angle with respect to xi minus 1 is that is 0 and 1. So what is that? That is 0. Those two are parallel. So now the next is ai minus 1. So there is no distance as well. So this is also along x1. So this is also 0. Then d1, that is along zi we have to measure what? The distance. So here along zi, that means z1, the distance of this point is again 0. But and there is a rotation which is changing. So this is theta 1. So first joint, the TH parameter will be 0, 0, 0 and theta 1. Now for second, what we have Z2, that is this one, and we have Z1 here. Now what we have to find, the alpha I minus 1 is that angle between Z1 and Z2 from x1 axis. So here we have x1 axis, right? So that is xi minus 1 for the Z2. So if we take your if you take your thumb on this x1 and try to rotate Z1 so that it coincides with Z2, what will happen? It will go like this, right? So x1 is upward. So if you put your thumb upward and Z1 is facing my side, so if you curl, so we know that we have to move what 90 degree to make this Z1 parallel to Z2. So we know that for DH parameter, we take this RHB, right hand rule, thumb rule, to right hand thumb rule as positive or conventional. So here it will be 90 degrees. So for second joint, alpha I minus 1 will be pi by 2 and ai minus 1. Ai minus 1 is the distance between these two along xi minus 1. So along x1 and x2, what is the distance between? So we know that x1 along x1 there is no distance between the thing. So this will be what? This will be again this will be 0. And then we have di, that is measured along z. So here we have this is z2 and this is this one. Z1 is here. So we can see here this Z2 is along this, and if you measure along Z2, the distance between x1 and x2 is nothing but d2. So that is the a thing which is measured by T1. So distance between the x1 and x2 along Z2. So that is nothing but D2. And now we have this thing ZI. So the theta I. So theta is what? So from Z2, that we have to measure x2 and x1, the angle between x1 and x2 along Z2. So you can see this both are parallel. So there is no angle. So this is no angle difference. So this is 0. So this is for joint 2. Similarly, for joint 3, what we can write? So this is Z3, this is Z2. So alpha I minus it was how you can rotate from Z2 to Z3 along X2. So if you again take your finger, or sorry, your thumb above and try to rotate Z2 to get Z3, how will you go? It will curl like this. So if you look at here, first you have to go 90 degrees, so it will face away from me, then again 90 degrees, so it will face this side, and then again 90 degrees, then we'll finally get this side. So it will be nothing but 3 pi by 2. So alpha I minus 1 is 3 pi by 2 for this one, 3. And then if you look at AI minus 1, so AI minus 1 is what? Is the distance between Z2 and Z3 along X2. So there's no distance between Z2 and Z3, so this will be 0. And then we have to find this one di. So di for what? This third one. So this will be measured along zi. So di is nothing but the distance between x2 and x3 along zi. So there is no distance between x2 and x3. Both are coinciding. So this is 0. Now uh, now we have to find theta I, that is the distance or the angle between x2 and x3 with respect to Z2. So how will you find it out? So now again, the angle finding, you point your thumb into Z2 direction and try to bring what x2 to x3. So what we'll have? We have sorry, Z3 direction and try to find, because we are here finding Z3. So Z3 and we try to find. So what we'll have? If we the Z3 is pointing towards me, so if we curl our finger, so if you can see the x2, to make x2 coinciding with x3, first we have to rotate by 90 degree here, then again 90 degree towards me, and then again 90 degree to get is parallel to x3. So this will also be 3 pi by 2. So this is the DH parameter for all these three joints. And so the question here is that we want to find this, they wanted to know about the DH parameter, the second joint. So DH parameter second joint will be pi by 2, 0, D2, 0. So you can see here, correct answer is pi by 2, AI1 is 0, then theta is 0, and DI equals to D2. Right. So this is the correct answer. Hope you understood the process how to find the DH parameter, this given example. Now let us move to the another example. So here also we'll try to find the DH parameter of joint 1, 3, and 4. So I will skip joint 2. I will try to find this for this 1, and then 3 and 4. So let us do that. So again, what we have to do, we have to first make this table. So of these four parameters, which are uh, alpha I minus 1, AI minus 1, then we have DI, then theta I. And this is serial number that represents the joint number. So let us look into joint 1. So this is joint 1. So this is Z1. So alpha I minus 1 is what? We have to find out the angle between Z0 and Z1 along xi. So let me write here. We are looking at two with respect to xi and these two with respect to zi. So that you'll always remember. Now, with respect to xi, so Z1 we have x0, right? So with respect to x0, if Z1 and Z0 have what? There is no angle difference. So this is alpha I minus 1 is what? 0, because both are coinciding. And then AI minus 1 is the distance between distance between Z0 to Z1 axis and along X0. So as you can see, along X0, there is no distance, and these are coinciding. So this is also 0. And then we have to find this DI. DI is along ZI. So along ZI, what is the distance between X0 and X1? So this is what X0 and X1. So this distance, so suppose this distance is D1. So you can write it as D1 here. And now this theta I. So suppose this joint one is nothing but the rotation. So we can have this as, so there's zero difference between 0 and Z1, and but this rotation can be represented by theta because this is an active joint. Suppose it is an active joint. Now look into the second joint. So second joint is here. Now if you look at the second joint, we have Z2 pointing towards me and X1 like this. So we have to find out what Z2 and the angle between Z1 and Z2 along X1. So how will you rotate Z1 with respect to X1 so that it will coincide with Z2? That is alpha I1. So again, point your finger upwards to grab Z1 and try to rotate along X1. So sorry. So you should point to your fingers or your thumb towards X1 because we are rotating around X1, and this your fingers will represent Z1. So if you rotate Z1, so it will take how much 90° towards me to get this Z1. Z1 coinciding with the Z2. So we have to rotate 90° to get this Z1 towards me. It will become like this one. So this is nothing but pi by 2. Then AI minus 1. So AI minus 1 is again this distance between Z2 and Z1 along X1. So what is this? So suppose this is something A1 or A2. So this will be A2 because this is the distance A2 from Z2 and Z1 along X1. So this is A2, some constant. And then we want to find DI. The DI is nothing but the distance between X1 and X2 along Z2. So along Z2, there is no difference. So this is 0. And theta. So this is what theta I. So 2 and so theta is nothing but we have to find out the angle between X2 and X1 along Z2. So these two are parallel. So this angle is also what? 0. But you see this, if this is an active joint, so this will be rotating along Z. So this X2 will be changing. So we can have this as theta 2, right? So this is for 1 and 2. Now let us go to the joint number 3. So joint number 3 is here. Now we have Z3 upward and Z2 this side. Now this alpha I minus 1 we have to find. So alpha minus 1 we have to measure along X2. So along X2, what is the angle which you have to rotate Z2 so that it coincides with the Z3? So again, take your finger out in terms of X2 and try to rotate Z2. So if Z2 is towards me, so you have to move like this. So it will have to rotate 90° here, and then again 90°, and then again 90° to go up. So right. So this way 90, 90, and 90. So it will be 3 pi by 2. So Z2 will become parallel to Z3 along 3 pi by 2. Z3 along X2 if you rotate by 3 pi by 2. So this is what alpha I minus 1 for 3 and AI minus 1. So AI minus 1 is nothing but the distance between Z2 and Z3 along X2. Right. So X2 and X3 along X2, there is no difference between Z2 frame or Z3 frame. So this is 0. And so now DI is distance between X2 and X3 along Z2. Sorry, and here we are talking about 3. So the distance between X2 and X3 along Z3. So along Z3, we have a distance, this one, this one which is represented by green here. So suppose this is D3, so we can write it here as D3. And if this is again a rotation joint, so we'll have an angle here as theta 3. So these are the for the three parameters. Similarly, we can do it for fourth link or other fourth joint. So I'm leaving to here only. The fourth one you can do by yourself, having understood this whole process. So let me move to the next question which we have. The next question is that for inverse kinematic problem, the numerical method can be applied to all kinds of serial or robotic manipulators. Right. The question is for inverse kinematic problems and this numerical methods. Now we know that the forward kinematics and inverse kinematics. Right. The forward kinematics is what uh, we are we have been given with x, y, z in the forms of theta 1 and theta 2. Right. And this is opposite of that. That means we have to find the x, y, z's are given. We have to find theta 1 and theta 2 so that x, y, z. Right. Now, if take a manipulator, suppose this is our point of interest where we want to go, and this is the base, and this is supposed to our manipulator. There are at least there are two ways in which we can approach this way or this way. So, similarly, for more complex robots, we'll have multiple solution to reach one point. Right. Suppose this is a point. So we have multiple orientation to reach this point. So for inverse kinematics, we have multiple solution and for finding these solutions, always this closed form analytical solution is not available. So for that we generally go for what numerical methods, and we know that numerical methods will be able to solve this type of question. Even if we have uh, closed form solution, we can use numerical method to find it. But the problem with the numerical method is that this is just an approximation, and suppose this is a function and we want to find it out this minima or this minima, or suppose this is a function we want to find this solution. If we start from here, solving, we may end up with this solution. So this is called as local minima. So the problem with the numerical method is that it may stuck into local minima, but the thing is it can solve all type of problems. So all kind of serial robotic manipulators, uh, whether they have closed form or don't have closed form solution for finding this theta 1 and theta 2 or joint parameters given the x, y, z, we can use numerical method. So this is correct. So the correct answer for this question is true. So we can, for inverse kinematic problem, the numerical method can be applied to all kinds of serial robotic manipulators. Right. Now let us move to the last question for today session. So this is another question where we have to again find the DH parameter. So here also I will like to have, so how many frames we have? We have Z0, Z1 and Z3, right? And Z2. So let us find for all these. So again, for DH parameter, what we have, first we have to make this table. So let us the table. So we have alpha I minus 1, then we have AI minus 1, DI, theta I. The alpha I minus 1 and AI minus 1 is what? Is measured with respect to xi minus 1, and DI and theta I is measured with respect to Zi. Great. So let us look for each of the joints. So for joint 1. So what we have for joint 1, so let us look here. So joint 1, so we have Z1 here. So Z1 is parallel to Z2, or rather it's coinciding, and X1 is here, right? So we have to check whether the angle of Z1 is Z0 along X1. So So we can see along x1, this both are coinciding. So alpha a minus 1 is 0. Now a minus 1. So a minus 1 is what? The distance between z0, z1 along x1. So there is no distance or there is no separation between z0 and z1. So this is also 0. Then we have di that gives the distance between xi and xi minus 1 along z1. So this is z1 direction, and the difference between x0 and x1 is 0 because all are coinciding. So this is also 0, and this is a rotational joint. So what we have, this is theta 1. Now let us move to the next. So now we have what? We have second joint. So second joint is here. So we have Z2. Now what we have to look? We have to look into how we can rotate Z2 so that it coincides, or rather how we can rotate Z1 so that it coincides with Z2, and that rotation has to be done along xi minus 1. In that case, or if you're talking about 2, link 2, or sorry, joint 2, we have to look around x1. So what we'll do again, we'll take our thumb outside and point it towards x1 and try to rotate z1. So z1 is pointing towards me, and we have to point upwards. So how will you rotate that? So it will rotate into, first z1 will rotate like this, and then again 90-degree, and then again 90-degree, so that it will go upwards because I'm pointing towards my side to pointing upwards. So 180-degree to pointing from inwards to outside, and then above for pointing upwards, it will again 90 degrees. So it will be pi by 2 plus pi by 2 plus pi by 2. So that is 3 pi by 2. So we need 3 pi by 2 of rotation of Z1 along X1 so that it coincides with Z2. So that is our alpha I minus 1. Now, if we look about AI minus 1, so AI minus 1 is the distance between Z1 and Z2 along X1. So you can see here that this is the X1 direction. So along X1, the Z1 and Z2 are what? Coinciding because there is no distance between along X1. So this is 0. Now, uh, now let us look into DI. So DI is what? This is measured along ZI. That means we have to measure along Z2. So along Z2, what is the distance between these two frames? So here is Z1 and here is Z2. And along Z2, the distance is D2. So here, this is D2. Now, uh, this is theta. Now, what will be the theta here for Z2? So the Z2 theta will be, now here, as you can see here in the question, it is written that it is an active rotatory joint. So this is a rotatory joint, and it will move around Z. So this x2 will be keep on moving, or this is x2, this x2 will keep on changing along this Z2. So the this theta is nothing but measured along Z2, the angle between x2 and x0. So initially it is parallel, so this is 0, but this can be rotated. So suppose this is theta 2. So this is nothing but, you can write it as theta 2. So this is for 2. Now for third, so third frame what we have Z3 here. So Z3, from Z2 to Z3, the angle along x2 is what? So if you point to your fingers or the thumb around x2, and Z2 is upward, so if you rotate 9 by 90-degree, we'll get Z3. So this is nothing but pi by 2, and so, and then AI minus 1. So that is the distance between Z2 and Z3 along X2. So there is no distance here. So this is 0. Then D2. So distance between Z2 and Z3, sorry, X2 and X3 along Z3. And as these are coinciding, so this is also 0. And this is just a part. So there is also no rotation because we have already taken this it here. So this is just also 0. Right. So This is the TH parameter which you are looking for. So now here in the question they have asked us the second joint, and they've also said active joint, which we have taken as theta 2. So the correct answer will be 3. Alpha I minus 1 will be equals to 3 pi by 2. AI minus 1 equals to 0. Di equals to d2, and theta equals to theta 2. So here if you see, for alpha I minus 1 is 3 pi by 2, this one. So this one is the correct answer, which will get in this case. So with this, we conclude all the questions, almost all the questions of the last year's assignment. So I have not taken few of the questions which are repetitive in this year's assignments, and that has to be done by you guys. So hopefully you'll be able to do with the help of today's session. So that's all I have for today. If anybody has any questions, you can write in the chat box, or you can unmute and tell. I will wait for 2 minutes. Thank you. Okay, as there are no more people in this class, so let us in this class today. We'll meet again next Sunday at the same time with week 4 assignments. Thank you.